they want you to look at this table and find the vertex. So it's probably going to be a quadratic. It's going to be a parabola. So your vertex is going to be the point where it turns around and starts going the other way, like this one, or if it's upside down, your vertex is either a maximum or a minimum. This would be a maximum right here, the highest point. This would be a minimum. So let's look at your table. Okay, from 25 to 10, that's going down 15. Okay, from 10 to 1, that goes down 9. From 1 to negative 2, that goes down 3. Then from negative 2 to 1, that turns around and starts climbing, that goes up 3. 1 to 10, that goes up 9. 10 to 25, that goes up 15. So your vertex is right here. Your vertex is at the 0, negative 2. So the vertex, that's where it turns around and starts going the other way. So your axis of symmetry, if you have a vertex at 0, negative 2, right there is your vertex. Your axis of symmetry is the vertical line that goes right through there. So it is x equals 0. The number of x-intercepts, so if we've got a negative 1, up 1, a dot right there, and then over 1, up 1, so your parabola is going to look something like this. So the x-intercepts, there's going to be 2 of them. It's going to cross the x-axis once on each side of the vertex. So there's going to be 2 x-intercepts. Is the vertex a maximum or is it a minimum? And it is going to be a minimum because that's the lowest point on the graph. Nothing is lower than the vertex, so that's going to be a minimum. Okay, if you are given a picture and you're asked to write a function, there's 2 forms that are going to be easy. They're either going to give you the zeros, which in this case this is what they've done, or they're going to give you the vertex, and you've got to write it in vertex form. So if they give you the zeros, let's use the zeros. So the zeros, they've given us a negative 4 gives you a 0, and then 1 gives you a 0. So the model for the zeros is going to be y equals a times x plus or minus some root times x plus or minus some root. And these roots are your zeros. So it's going to be y equals a x, and the only tricky thing is if your 0 is at negative 4, 0, this is actually going to be plus 4, and if your 0 is at 1, it's going to be minus 1. Because when I take 1 and I plug it in for x, 1 take away 1, that's giving me the 0. Or if I take negative 4 and I plug it in for x, negative 4 plus 4, there's my 0. So in the model, they're going to be opposite of what they are on the graph. Okay, now A, this is the orientation of your parabola. It's upside down and right side up. When it speeds up the growth or it slows it down, so it's going to make it wider, it's going to make it skinny. To find the value of A, you need to choose another dot. Choose any of these other dots and let's plug it in. So if I choose this dot right here, this dot is 0 and a negative 4. Let's take this and let's plug it into our model. So the 0, that's going to go in place of the x's, and the negative 4 is going to go in place of the y. So in place of y, let's put -4. In place of a, there's nothing to put. That's what we're trying to find. So leave it as a. In place of x, let's put 0 plus 4 times 0, take away 1. So -4 equals a times 0 plus 4 is 4. 0 minus 1 is a -1. So a times 4 times a -1, you should have this. -4 equals -4a. So divide a by -4, divide this by -4, and we've got a is equal to just 1. So if a is equal to 1, then your final answer is going to be y equals 1. And you don't even really need to write the 1. Let's go x plus 4 times x minus 1. And you could leave it like that. Okay, but now if they give you multiple choice, and if this is not one of your multiple choices, this is a trick they might do. If this is not one of your multiple choice options, then they probably simplified it. They probably distributed these through. So they probably did x times x is x squared. X times a -1 is a -1x. 4 times x is a plus 4x. And 4 times a -1 is a -4. And then you can combine your like terms. So this is the exact same thing as x squared plus 3x minus 4. So these two are the exact same graph. One of them is factored and one of them is just standard form. Okay, imaginaries. Imaginaries multiplied, you got to remember this, an imaginary times an imaginary is going to turn real. So if you have an even amount of them, it's always going to be real. I times I is going to be a -1. So I squared is equal to a real number, and that's a -1. So if you've got 14 i's, how many squares are in 14? And we look at this as there should be 7 squares in 14. So 7 squares in 14, that means there's going to be a -1. There's going to be 7 of these -1s. So -1 times itself 7 times. And because a -1 times itself an odd number of times, your answer is still going to be a negative. So if there's 15 imaginaries, how many squares are in 15? And it's kind of the same. There's going to be 7 squares in 15, but then there's going to be 1 left over. So 7 squares, that's a -1 times itself 7 times, which is just a -1. So it's a -1, but now you got to times it by this 1 imaginary left over. So -1 times an imaginary is going to be b, a negative imaginary. Now if you've got 16 imaginaries, how many squares are in 16? And there should be 8 squares in 16. But every square is a -1, so if you have a -1 8 times, you're going to end up with a +1. That's going to be C. And then if you have 17, that's the same as 8 squares times 1 left over. That's 17 i's. So 8 squares, that's just a 1, and a 1 times I is just I. So this one's got to be A. Okay, the quadratic formula. So we're going to give you some quadratic functions. Let's use the quadratic formula. The quadratic formula, y equals, or I guess it's not y equals, it's x equals a negative b plus or minus square root of b squared minus 4ac all over 2a. So your first move before you do anything is we got to figure out the value of a, the value of b, and the value of c. And we can't do that until you get everything on the same side. So we got to move this 9 over. So if we minus 9 from this side and minus 9 from this side, we're going to have 2x squared minus 4x plus, what is that, 12? Okay, now, as soon as we got everything on the same side, you can figure out what your A is, what your B is, and what your C is. So A is how many squares you've got, so A is going to be 2. B is how many x's you've got, so B is going to be a minus 4, and then C is going to be how many numbers you've got. C is going to be 12. So now that you know your A, B, and C, all you do is plug them into the formula. So x equals a negative B, so it's going to be a negative 4 plus or minus the square root of B squared. So it's going to be, you got to put this in parentheses, negative 4 squared minus 4 times A times C. And all of this needs to be over 2 times A. So now you just start cleaning it up. A minus minus 4, this needs to be a plus 4. And then in your square root, a negative 4 squared is a negative 4 times negative 4, that's positive 16. But now in your calculator, you can do a negative 4 times 2 times 12, and this should be a negative 96 all over 4. So now 16 minus 96, so your next step, we've got 4 plus or minus the square root of a negative 80 all over 4. Okay, now you got to clean up the square root of a negative 80. And because it's negative, you know it's going to be imaginary. So your next move is going to be 4 plus or minus, let's take the imaginary out, plus or minus square root of 80 all over 4. Now there's probably some squares in 80 that we can factor out. So let's rewrite 80 as its prime factors. 80 is the same thing as 10 times 8. 10 is 2 times 5. 8 is 2 times 2 times 2. So let's swap out 80. So we're going to go 4 plus or minus an imaginary. Let's trade 80 for 2 to the 4th times 5. All divided by 4. So now let's pull out some 2's. So we've got 4 plus or minus an imaginary, and 2 of these 2's are going to come out. So 2 squared comes out, the 5 stays in, and 4 on the bottom. So we've got 4 plus or minus 4i times the square root of 5 all over 4. And you can divide both of those pieces by 4. If you divide them both by 4, 4 divided by 4 is 1, and 4 divided by 4 is 1. So your final answer, 10 steps later, your final answer, we've got 1 plus or minus 1i times the square root of 5 for x. Okay, let's do one more. Let's look at the one right below it. So your first move, you got to get everything on the same side. So if you move this 6 over, if you minus 6 minus 6, that will leave you a 6v squared plus 2 is 0. So let's identify A, let's identify B, let's identify C. A is how many squares you got, A is 6. B is how many x's you got, and there are none, so B is going to be 0. And C is the constant, C is the number all by itself, so C is going to be 2. So A is 6, B is 0, C is 2. Now let's start plugging them into the formula. So x equals a negative b plus or minus the square root of b squared minus 4 times A times C all over 2a. So the zeros are going to be easy to work with, so we've just got plus or minus. A minus 4 times 6 times 2 is going to be a minus 48. And then on the bottom, a 2 times a 6 is going to be a 12. Okay, now because it's a negative, I know it's going to be imaginary, so I'm just going to change that. Plus or minus its imaginary square root of 48 over 12. And now let's break up 48 and see if we can pull out any squares from the 48. So the 48 is the same thing as 6 times 8, and that's a 2 times a 3, and that's a 2 times a 2 times a 2. So let's trade 48 for 2 to the 4th and a 3. And then on bottom we got a 12. So now let's pull our 2's out. And we should have plus or minus 2 squared times I. 3 stays in and 12 is on the bottom. And 2 squared, that's the same as 4. So if I got plus or minus 4i times the square root of 3 over 12, my 12 and the 4 play together. The 12 cannot play with the 3, it's got to play with the 4. So 4/12 is the same thing as 1/3. So my final answer is going to be plus or minus 1/3 I times the square root of 3. Okay, let's go backwards. So this time they give you the roots. The solutions are x equals -2 and 3. So that means it's got to look like this. X, X. So what was it that gave you, if your roots are where it crosses 0, so let's put this equal to 0. So this has to be x plus 2 and x minus 3. So if they give you the roots, we got to work backwards, and if you plug this in, it's got to give you a 0. So if you plug in a -2, you must add 2, because that gives you a 0. And if you plug in 3, you got to take away 3, and that gives you 0. So x plus 2 times x minus 3, and that's not any of the multiple choice, but if you times it through, x times x gives you x squared. X times a minus 3 is a minus 3x. 2 times x is a 2x. And 2 times a minus 3 is a minus 6. And if you combine those, you get x squared minus x minus 6. So that should match up with B. Okay, 19 is kind of a trick question. If your solutions are 4i and a -4i, so we got x equals 4i and a -4i, it's going to be the same. 0 has to be x. So if I plug this 4i in to get 0, I got to do a minus 4i. And if I plug this 4i in, then I got to do plus 4i. So they're always kind of opposite. Okay, now that's not either A, B, C, or D, so let's times it through. X times x is going to give you your x squared. X times 4i is going to give you 4i times x. A minus 4i times x is going to be a minus 4i times x. And a minus 4i times a plus 4i. Minus 4 times 4 is a minus 16. But I times I is I squared. So now your 4ix minus 4ix, those are opposites, so those zero out. So we just got x squared minus 16 I squared, but I squared is a -1. So negative 1 times a minus 16 is a plus 16. So this is it. X squared plus 16 is 0, but that is not A or B or C, but it is D. Oh wait, hold on. That's not D, that's not D. It's C. Because look at C. If I bring this, if I plus 12 here and I plus 12 here, then I've got x squared plus 16 equals 0. So C is going to give us the same thing what we've got here. So they just manipulated a little bit. They kind of purposefully wrote it as a trick question. So which one of those can you change in to be x squared plus 16 is 0? Okay, now let's look at these next ones. Let's skip 20. Let's look at 21. If your answer is 8, so if you got just x equals 8, then it's going to be this. It's going to be x, and that's going to be 0. So in both parentheses, it should be minus 8, minus 8. Because if you take and put x in for both of them, that's going to give you your zeros. So x minus 8 times x minus 8 is going to be x squared minus 8x minus 8x. Minus 8 times minus 8 is a plus 64. So minus 8x and a minus 8x, we got x squared minus 16x plus 64. And that's going to give us our 0, and that one matches up with B. Okay, these quadratics, some of them are easy if you use factoring, some of them are completing the square, and some of them are quadratic formula. So the first thing you got to do on all 4 of these is you got to get everything to the same side. So let's move this 4 over, and let's move these squares over. So let's minus 4, let's minus 4, and let's minus 8p squared on both sides. So the first one should give you 3p squareds minus 3p's minus 13 is a 0. The second one, if you move these both to the left, should give you just an n squared minus 4n minus 42 equals 0. The third one, if you move everything over to the left, you should have x squared plus a 4x minus 23 equals a 0. And then the last one, if you move everything over, if you minus 4n, that's just 1n squared. Minus 7n, that's minus 4n. Minus 12 equals 0. Okay, now let's look at them. And your squares, if your squares start with 1, those are okay, those are nice. So those look good, but this one, because my square starts with a 3, I'm going to automatically use quadratic formula. So quadratic formula goes to 22. If your square is not a 1, then let's use quadratic formula all the time. Okay, factoring on 23. Can you factor it? Does there exist numbers that times and give you a negative 42, but add and give you a negative 4? So if you can find those numbers, then factoring is going to be easy. If you can't, then let's complete the square. So negative 42 and 4, what is that? 42, and if you have to make a list, I know 1 and 42, 2 and 21, 3 will go into it. How many 3's are in 42? 3 and 14, 6 and 7. So here's my options. Can I make a -4 with any of these numbers? And you look them over, and I don't think you can. So then 23, if we can't factor it, let's use completing the square. Let's use B. Okay, the next one. How about a -23 and 4? Can you multiply and get a -23, but add and get 4? And that answer is, I think it's the same as one we just did. Nothing's going to times give you 23 except for 1 and 23. So this one cannot be factored. So let's use complete the square again. The last one, can you times and get a -12 but add and get a -4? I'm with, if you use a no, that's not going to work. What do you got to use? Yeah, that will work. A -6 and a +2. So -6 times 2 will give you -12, but if you add them, it'll give you -4. So if you can factor it, then you want to use factoring. So let's go over the factoring and one of the complete the squares. Let's look at 23. So on 23, if you cannot factor it, so we've got n squared minus 4n minus 42 equals 0. Yeah, where's your help pass? So you can't factor it because of the c. They gave you a bad c. So if we've got a -42 and a -4, let's replace this c with something of our own choice. So it gets kind of creative. So here we go. If we've got n squared minus 4n, let's fill in the blank. So let's put what we want here. So in place of the minus 42, so I want to create a perfect square. So you look at the b. What number at itself is going to give you a -4? And it's going to be a -2 and a -2. So a -2 and a -2. And if you times those together, that's going to give you a +4. So the number you want right here is a +4. But if you put a 4 here, then you got to turn around and take the 4 away, because you can't go adding 4s. If you add it to this side, I guess you could add it to this side. If you add it to the left, you got to add it to the right. Or if you add it to the left and put a -4 right next to it, that's just like adding a 0. So either way is legal. So if we look at this, and we've got your n squared minus 4n plus 4, it's n minus 2 times n minus 2. And then these guys, if we've got your -4 and -42, if you want to move these over to the other side, so if you put this -42 over here, it's going to be a 42, a +42. And then if you take this -4 over here, that's going to be a +40 or +4. So if you add those together, you're going to have a +46. Now you got a perfect square. So n minus 2 times n minus 2 is going to be n minus 2 squared equals 46. And now you can undo the square. So if you undo the square, you're going to square root this, and you're going to square root this. This square root cancels that square, so you got n minus 2. And if you take the square root of 46, you got to do both the plus and minus square root of 46. And now you got to pull some squares out of 46. So 46, what's going to come out of 46? So 46 is the same as, what is that? The same as 2 times 23. And maybe I don't think there is any squares in 46, because 2 is done and 23 is done. So maybe 46 is done. So now to solve for n, you just add 2 to this side and you add 2 to this side. So you got n equals 2 plus or minus the square root of 46. And that's your answer. The factoring one, so this number 25, the factoring is the easiest there is. So if you've got n squared minus 4n minus 12 equals 0, that's the same if you factor it. It's n minus 6 times n plus 2 equals 0. So then your n's got to be either a 6 or a negative 2. So when your answers are integers, they're easy, but it's when your answers are irrational, that's when it's kind of tough, it's hard. Alright, so the trig, they want you to solve each triangle. They want you to find angle A, angle B, angle C, side A, side B, side C. So angle C, let's fill in what we know. Angle C is 90. And this is little c, this is little a, this is little b. So little a is going to be 6, little b is 13. So there they go. They give us 3 pieces. We've got to find the other 3 pieces. You can find little c. You could do Pythagorean's theorem. You could go 6 squared plus 13 squared equals c squared. So 36 plus 169 equals c squared. And then probably calculator, because they want to round it to the nearest tenth so that we can just go to decimals, which is nice. 36 plus 169, 205 is going to give you your c squared. So now you square root of the 205. So c is like 14.3. Okay, now the only way to figure out the angles is now we've got to use the trig. So let's put theta right here. If you put theta in A, that means this is your opposite, this is your adjacent, and this is going to be your hypotenuse. So now let's make a fraction with 6 and 13. So which trig ratio is going to use the opposite with the adjacent? And it's got to be tangent. So let's use the trig ratio of tangent. So let's do the tangent from A. And the tangent from A is going to be 6 over 13. Okay, now I need to solve for A, so I got to ditch tangent. I need to get rid of tangent. The only way you can get rid of tangent is if you do the inverse tangent here. You got to do the inverse tangent here. So on your calculator, if you do the inverse tangent of 6/13, that will give you the angle. So if you know the fraction, you can work backwards and get the angle. So inverse tangent of 6/13 is, A is about like a 24.8 degree angle. So if A is 24.8, B, I don't even need any trig. I'm just going to do B. I'm going to do 90 minus 24.8. Because I know a 90 and a 90 have got to be 180. So 90 take away 24.8. B is like a 65.2. Div K. Same thing. You gotta find A, you gotta find B, you gotta find C. You gotta find A, you gotta find B, you gotta find C. Big A went haywire. So here we go. Angle A, angle B, angle C. Side A, side B, side C. Angle B 51 degrees. Angle C 90 degrees. So that means angle A they give to us. Because A and B have to add and give you 90. So this angle A has got to be 39 degrees. So little a is 12.1. Now this is little b and this is little c. So if you put theta right here, if you put theta on b, if we're looking from b, this is going to be the opposite, this is going to be the adjacent, and this one's going to be the hypotenuse. So now let's set up a fraction, but let's use 12.1 because I know the number, I know what it is. And I can use 12.1. I don't know C or I don't know B, so it doesn't matter which one I use. If I use B, if I go 12.1 with B, I need to use the adjacent with the opposite. So it's got to be tangent. So the tangent of where I'm at, which is 51 degrees, equals the opposite over the adjacent, 12.1. Okay, now I want B, so I'm going to get rid of all this 12.1. So instead of divide by 12.1, I'm going to times this by 12.1, times this by 12.1. So 12.1 times the tangent of 51. And that little b is about 14.9. Okay, then little c, I'm going to use 12.1 with c, so that's adjacent and hypotenuse. So that's cosine of where I'm at. Cosine of the 51 degrees equals the adjacent, 12.1 over the hypotenuse. Okay, now when the variable's on the bottom, you just switch these two places. So if I switch these, if I take the c over here and bring the cosine of 51 here, c is going to be 12.1 over the cosine of 51. So 12.1 divided by cosine of 51. So c is going to be 19.2. Branson, give a shout out in the video. We're making a video. Shout out.
Sup, guys? This is the Branson Pratt here. In the math room, you know.